Hello everyone, welcome to School's Not Out, your daily classroom for CSEC and CAPE students. You can watch this lesson real-time on Televisions Jamaica's YouTube channel or on onespotmedia.com. We also are live on Music 99 and gojamaica.com.
If you have questions on today's subject, CSEC Math, you can send them in to Television Jamaica's Facebook page or Instagram at television_Jamaica. Today, we're getting into part 2 of vectors. I am Karima Mundell Thomas.
And I am Latoya Shariah.
So, Latoya, here we are.
Yes.
And we are looking at part 2 of vectors for this morning. And we want to see what are some of the objectives that we have for this lesson. So last week we would have explored, looking at how to write our vectors in the form x, y. We also looked at how to differentiate, well, that's what we're going to be looking at today, how to differentiate between position and displacement vectors, and also how to find the resultant vector, how to determine the resultant vector for 2 or more given vectors. Is it on? So, let's do a recap, shall we?
So last week, we did discuss that a vector is a quantity that has magnitude and direction, while a scalar is a quantity that only has magnitude. A vector can be written in the form xy, where x describes horizontal movement and y describes the vertical movement. For example, we have here vector AB is equal to 3, -1, which means that we have a movement of 3 units to the right, followed by 1 unit downward. So the negative here speaks to a downward movement.
So inverse vectors, we would have discussed this last class. They have the same magnitude, Latoya, but they go in opposite directions of each other. So for example, if I have vector AB, which is 3, -1, and its inverse vector BA, -3, 1, we're looking at these vectors and we're seeing that they are the inverse of each other. Please note that our +3 from our first vector, if we look over at vector BA, we're seeing a -3 in that position. And if we look at vector AB, we have -1 in our y position. And its inverse, vector BA, we have a +1 in that position. We also looked at equal vectors. They have the same magnitude and they go in the same direction. So 2 vectors are parallel. We discussed this last class as well, Latoya.
Yes, we did.
They are parallel if they are scalar multiples of each other. And that's quite interesting. For example, if I have vector xy, which is equal to 2, 4, and another vector qr, which is equal to -4, 8.
-8?
-4, -8, thank you so much.
No problem.
We can rewrite vector QR as -2, which now is a scalar that we're using, and the vector 2, 4. So we're seeing here that it's actually twice the magnitude, and we spoke about this last class. So this means that vector QR is equal to -2 vector x, y. And we're looking at that -2, and we're saying that the scalar multiple gives us some pertinent information about this vector. That -2 is indicating to us that this vector is going in the opposite direction, right? And the 2 is telling us that that magnitude is twice the magnitude of the vector.
All right.
All right, so we would have spoken about that, Latoya. We can move right along. So the magnitude of a vector can be found using the formula, the square root of x squared plus, added to y squared, where x is the horizontal movement and y is the vertical movement. And our example is coming up on screen. We would have discussed this last class as well. We'll pick up on this, Latoya, when we return from this break. More on schools not out right after this break. Stay tuned.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also...
Get moving! Home workout series with Jamaica Moves.
Jamaica move, mobilize, exercise. Jamaica move, Jamaica move, Jamaica move, mobilize, exercise. Come on, take a selfie, breathe.
Mondays, Wednesdays, and Fridays at 8:35 a.m.
Hi! We haven't left you out. It's Get Moving Kids.
Wall Street above, we're moving.
Home workout series with Jamaica Moves. Tuesdays, Thursdays, and Fridays at 2 p.m. on TVJ.
Get moving!
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also...
Welcome back to School's Not Out, your daily classroom for CSEC and CAPE subjects. We're on the second part of our lesson on vectors. Welcome back.
All right.
All right. So Karima, I have a grid here and I have some points. What do you notice about the coordinates of R and vector OR?
So I'm looking at that, Latoya, and I'm seeing where the coordinates of R, remember that you have to touch your screen for me if I need you to.
All right, so we have R here.
Right, so the coordinates at R, I'm seeing that X value as 1.
Okay.
And that Y value as 2.
Okay.
So that coordinate looks like 1, 2.
All right. So what about now the vector for
all right.
OR?
So the vector OR, we're noticing that the starting point is O and the end point is R. So we're looking at the movement. So I'm seeing a movement to the right. So that looks like a positive movement.
How
and it's
many?
1 unit.
Okay.
And then I'm noticing a movement of 2 units upward. And that looks like positive 2. So that vector is 1, 2.
Okay.
I hope I'm as bright this week as I was last week.
All right. So we have R at 1, 2, and the vector OR also 1, 2.
Interesting.
Same.
Yeah, interesting.
All
so they are the
right.
same.
Is it the same thing though for vector ST in terms of the coordinates for T and the vector ST?
All right, so I'm looking at the coordinate for T.
Right.
And I'm seeing where that X value is 5 and the Y value is 6. But when I'm looking at the movement from S, I'm looking at a movement to the right of 2 units, Latoya. That's a positive 2. And I'm seeing a movement upward of 4 units. So that's
1, 2 to the right, and 1, 2, 3,
4
4
units
upwards.
up. Right.
Okay.
So the coordinate for S, we said already was
For
5.
T.
For T, sorry, 5, 6. And the vector ST is 2, 4. So
4.
we're not seeing the same thing.
No, it's not.
I wonder what's different.
So why do you think that the vector OR is the same as the coordinates for R, and then vector ST is different for the coordinates for T?
You know, I'm thinking, because I'm looking at that point O.
Right.
And that looks like the origin, isn't it?
O origin.
Right, so that point is 0, 0.
Right.
So I'm thinking that because OR starts from the origin, that is why the coordinate for R and the vector OR were the same. And I know there's a special name for that, you know. Thank you.
Position.
Position vector. Thank you so much. So vector OR begins at the origin, and so we call it a position vector.
While ST does not begin at the origin, and so it is now a displacement vector.
All right, so these are important points to note, Latoya, because especially that position vector, it's a term that is quite commonly used in our CSEC exam questions. And so it is expected that the students should readily know what it means when CSEC informs them that such a vector is a position vector.
Right. So if you are reading a CSEC question and it says that vector AB is a position vector, for example, then definitely you know that it is coming
say AB
from
a while ago?
OB.
Oh, okay.
Sorry, vector
right.
OB.
Thank you.
Right, vector OB or OC or OD is a position vector, then you know that it's coming from the origin. Remember that.
All right.
All right. Now we're moving into some nice things now.
Yes, I see pizza, game place, bookstore. Let's see what's happening here.
All right, so this is saying, both John and Mark left the bookstore to go to the game shop to purchase a game. However, John made a stop to get pizza on his way there.
All right.
Love him, Belly. Let's look at each boy's movement. So, John went from bookstore pizza to the game shop, while Mark went straight to the game store from the bookshop. All right, so
we're basically renaming the places because we want to get rid of the picture so we can see clearly, you know, what's happening on this Cartesian plane. So we're going to be naming the bookstore point A, we're going to be naming the pizza place point B, and of course the game shop, we're naming that point C.
All right, here we go.
All right.
So John traveled along vector AB, then along vector BC, right?
Right.
Mark traveled along vector AC. Here's my question now. Did they both start and end at the same point?
Well, we know that they were both leaving the bookstore at A. So I'm saying that they started out from the same point. And the question is, did they also end at the same? Of course, they met up right at C at the game shop. So I'd say yes.
Yes, they indeed did.
Interesting.
Right. So, let's add vectors A, B, and BC and compare to see if they indeed would have started at the same place and ended at the same place. So for vector AB, we know that it's 3, -1.
No, I think you meant -1.
-1, I
3.
don't know why, maybe it's the glasses.
-1,
I'm seeing
3.
upside down. -1, 3. And then BC is 4, 1.
All right. So we're adding these vectors and we're checking, as the question says, we're comparing our result to the vector AC. We want to see if, you know, this is an example of displacement, and I think we would have spoken to that in the last class.
Right,
that's
right.
an example of a vector. And so we want to compare John's movement from A to B, followed by B to C, and we're seeing how does that compare to Mark's movement, which Mark never hungry, so he went directly from A straight to C. Now let's do that addition.
So when we added Mark's movements, we are getting a vector of
Actually, that's
3,
John's movement.
sorry. 3, 4.
All right, so -1 plus 4, and the addition is pretty simple. -1 plus 4,
Because we're just adding
to
the
4.
what? The what? What we're adding?
We're not going there again.
No, the corresponding.
So -1 is added to 4, and we end up with 3. And of course, 3 is added to 1, and we end up with 4. But we're at the point now where we want to do that comparison, Latoya.
Right.
So I want you to use your
My
finger
fingers
on screen, yes, to show our students. Look at that grid and see how is it that we got that 3, 4 for Mark's movement.
All right, so we're moving from A to C, right? So we
Correct.
always have to do our horizontal movement first.
Yes.
So that's 1, 2, 3.
All right, so we sit at 3.
1, 2, 3, 4.
All right, beautiful. So we're looking at that and they look like the same.
They actually are.
So when we added the 2 movements for John to that to each other, and
Right.
we compare it to that 1 movement for Mark, we noticed that
It's
they
the
gave the same
same.
result.
It's just that John took a different route than Mark.
So what conclusion can we draw from this, though, Latoya?
I'm seeing where I'm adding these 2 vectors and I'm getting back this 1 vector that is going in the same direction.
So
I add AB plus BC and I get AC.
So can we say then that AC is the resultant vector for vectors AB and vector BC?
I think the resultant vector, that sounds like a nice word.
Yeah, I think we
So
can
AC
conclude.
is the resultant vector of
Yes,
AB.
of vector AB and
and
vector
BC.
BC. Yes.
All right, sounds good.
Yep.
There you go.
There
AC
it
is the
is.
resultant vector of AB and BC.
Confirmation. We're bright.
We bright. You bright too.
Yes, of course, we are brilliant students
right.
in this class.
What if I wanted to find BC, but I only knew AB and AC?
All right, so we're talking about vector BC.
Right, vector
so
BC.
we wanted to find vector BC, and we only knew vectors AB and vectors AC. No.
I want to point out though,
All right, go ahead.
BC, from what we were doing earlier about the vector, so if we're doing BC and we don't know here, right?
Yes.
That means that I would have to go, because it says we know AB and we know AC.
So let's bring up AC on screen.
So I would
All
have
right.
to go BA and then AC.
Oh, I see what you're saying. Based on what we did earlier,
Right.
so we obviously have to start from B, because
Right.
we want to find this vector BC. So B has got to be my starting point.
Right,
Makes
right.
sense, right? And then based on what you're saying, we're moving from B to A.
Right?
Yes, and then we're going from A to C.
Because C is our ending point.
Good. And I'm
Right.
looking at that too, Latoya, and I'm noticing that that point A is common
Between
to those 2 vectors. So we
Yes,
have a
yes.
vector BA, so that would end at A, and then we have a vector AC.
AC.
But I want you to bring up some more things on screen, because we want to focus a little bit more on that vector
BC.
Not BC, we actually want to focus a little bit more on that vector AB, because notice now the question gave us, we know the vector for AB. But based on what we are saying, to make BC the resultant vector,
Right.
so we want vector BC to be the resultant vector, we are saying that any combination of moves must begin at B, I want to stress this, connect to a common point, and we identified that our common point in this question would be A, and you rightly said it should end at C, all right? So then, how does that affect the vector I was given? Remember now I got AB, so we need to know, focus on.
I see what you're saying. I see what you're
see
saying.
where I'm going with that.
So we were given the vector AB.
Correct.
However, we are starting at B and going to A.
Yes.
So now that is
We did it last week.
inverse vector.
Inverse vector,
Because it's
girl.
the same distance, but it's just a different direction.
The opposite direction to be exact.
Opposite, yes.
Right.
Yes.
All right,
now-
so let's bring up and see if we're right. Yes.
All right.
Oh
so
my
as we were
goodness.
saying, note that for vector BA, we are moving in the opposite direction of AB. So what would then?
Of
What do
vector
you
AB.
think would happen, viewers at home, to the vector -1, 3? Because -1, 3 is representing AB, but we are now traversing through BA.
All right.
So what do you think will happen?
Let's give them a couple of seconds and see if they learned
All
it
right.
last
So
week.
we're going that way now.
All right, so we're going in the opposite direction.
Opposite direction, but same distance.
All right. And so my vector BA,
Is
notice
now
that change. It's now 1,
negative
-3. And this is something we would have explored last class. So we looked earlier at the resultant and we just spoke about that. We said now BC is our resultant vector,
right.
for vectors BA
And AC.
AC. And so we're performing our addition here now in order to get the resultant vector BC.
All right. And just by verification, let's look at our, because we added.
But hold on, before you verify, so let's look at the terms that we added. So we had 1 being added to 3, and we got that 4. And of course, -3 being added to 4 gives us 1.
All right.
So verify that for me, Latoya,
so
on our Cartesian.
We're starting at B and we're going to C, right?
Correct.
Horizontal movement first.
Yes.
So we go 1, 2, 3, 4. That's what we have, okay?
Yes. And is that positive? Hold on. Which direction did we
I
go
went to
for that?
the right, and I know
Okay.
that a rightward movement is a positive movement.
Thank you.
And I went upward to C, and so that is also a positive movement.
All right. How many units up to C did we go?
1 to C. So it's
Okay.
1, 2, 3, 4 to the right, and
Yeah.
then 1 upward.
All
4,
right.
1.
Beautiful.
We were indeed correct.
Yes.
So whether you use a grid or by addition, your answer should be the same when finding the resultant vector of 2 or more vectors.
All right. Good
All
point.
right? 4,
Yeah.
1.
Okay. So here's my question before you get into that, Latoya. 'Cause
Yes.
we just looked at, as the heading said, we didn't mention it, but the heading would have said triangular law of vectors, and we saw where we had triangles working with.
Yes.
But my question to you is this.
Don't make the question hard, do you know? Go on.
No man. Oh, you must show. So question, does the triangular law of vector, does it work every time? Is it always a triangle that is formed? You know, these are questions that I think our students, you know, they're having, and they want to know whenever I'm finding a resultant vector for 2 vectors, which we had earlier.
Right.
Is it always the triangular law of vectors that we use?
You know what I've learned? Is that, especially the fact that it's called a law, it means that it won't work for every situation. It will work for particular situations.
All right, so let's
I'm thinking it
all right,
won't work
let's
for
see
everything.
what's happening with because you would have run ahead and I get a sneak peek at the
All right.
question. So let's look at this question. So two forces are acting simultaneously on a particle
P.
at P. Now,
All right.
I want to point out that word.
At P.
Before I even get to the at P, I want to
Okay.
point out the simultaneously.
Okay.
Yes, so we're looking at two forces, and when we say that they're acting simultaneously on the particle, we're
the
saying
same
that
time.
they're acting on the particle at the same time. And I want us to remember that in lesson last week, we would have
Yes.
spoken about some examples of vectors,
Yes.
and force was one of those
Vector quantities.
Good.
Yes.
And so when we're talking about force here, we know already from previous knowledge that we're looking at vectors.
Right.
All right. So they're acting simultaneously on a particle at P, and we can see on our screen P at its location, and we can see represented by those arrows, the vectors representing the force that's acting on P.
At P. I'm
At
getting
P, the particle at P.
I'm getting a at P vibe, meaning if it's at P, that means that P is our starting point.
All right, let's explore that a little bit more.
All right.
All right, let's explore that a little bit more. So what are they really asking us?
What is the resultant force of these two forces acting on the particle at P? What is the resultant vector
Yes.
of these two forces acting on the particle P?
So
All
I'm
right.
looking, but before I go any further, Latoya, I'm looking at this and I'm seeing where these two forces basically pulling P in two different directions.
Right, at the
these
same
vectors
time.
at the same time. So,
Yes.
so if we looked at it, one vector pretty much pulling P towards Q,
Right?
and there's another vector that is pulling P towards S.
Right.
Yes, so they are basically pulling P in two different directions.
At the same
that's
time?
at the same time, right? That's what I'm seeing here.
So, could I use the triangular law here? And so now I will be finding now QS as my but QS.
Because you made a point earlier that the
P is my starting point.
All right, very good,
And
very
so
good.
then the triangular law would not work here, because if I'm using the triangular law, I would be ending up finding now vector QS. And nowhere in QS is the word P.
All right, so we would have said that these vectors are operating on P pretty much at the particle that is
Right.
at P based on the question that was given. And so we can pretty much conclude that the resultant vector
Must start at P.
must start at P. So P
All
has
right.
got to be my starting point.
All
So
right.
that rules out for me, Latoya, using QS or SQ. It really doesn't matter which of those directions.
Right.
That vector is just out of the loop for us.
And it can't be PQ or PS either,
All
because
right.
those are the forces.
But I want to zoom in on something, because earlier we looked at something about a common point.
Yes.
So we said that whenever we're finding a resultant vector for two or more
but in this
vectors,
case, two.
right?
Right.
We established that our start point for this question is P.
Right.
So if I'm starting at P, I must be looking for a common point.
Right.
Yes, for these two vectors.
Yes.
And I'm starting at P. So if I start at P, I notice that one force or vector is going towards Q,
One vector is going
and
towards
one vector
Q.
is going towards S. So I'm not really seeing that common point coming out. And based on what we looked at earlier, that is important.
Yes.
If we are going to be finding the resultant vector. So, well,
You know what I'm thinking about? I know that in everything in math, it's interrelated and it's linking, and
Well, that's
a lot
true.
of times the previous information that you would have learned, you're supposed to use it
Word.
for the more complex
you know,
things,
that's
you know?
one of the reasons I encourage my students, don't block your mind against certain topics, because everything is
Intertwined,
related,
right?
So we would have learned some things last
I'm thinking about
class.
some parallel vectors.
Not just parallel, but equal.
Parallel and equal vectors.
Yeah.
So if I'm supposed to say now, connect some, so I'm going to put in this vector here. which would be now parallel and equal to PQ, just for argument's sake.
All right.
And then I'm going to put in another vector here that is now parallel and equal to PS. Right?
All right.
So I'm
Can we get a
now
label for that point, just for reference?
Oh, okay. So these, where these two new vectors meet now, I'm going to call it R.
All right, fine.
All right.
So we looked earlier and we said that we were short of, a common point.
Right.
Separate and apart from P or starting point.
Right.
Now I'm looking at that and you would have used a very important word. You talked about parallel and equal. And those are some of the properties of a particular shape. I wonder if our students know it. So we're looking at vector P, S, and we're looking at vector Q, R. And you would have said it, but I wonder if they caught on to it.
I don't know.
These vectors we said are
I think
parallel
so.
and equal. Yes,
I
and we
think
see
so.
that quadrilateral being formed, but there's a special name for it, Latoya.
But if we use parallelism, so I'm going to say, I don't know if that's the word, by the way.
So it's a parallelogram.
It's a parallelogram.
That's the word.
Right.
So we see a parallelogram being formed here. Now, I wish I could touch the screen, but I want you to outline for me vectors PQ. So follow that with your, yes. Do it again. I don't think our viewers were seeing that finger.
P to Q.
All right, and then we're going Q up to R.
Q, R.
That looks like an important point, because I see I'm going in the anti-clockwise direction pretty much, and I'm ending up at R. You know what I want you to do? Try
Go
P.
straight to P?
No, come back to P. No. Come back to
go
P.
back to
Because we're
P.
following the direction of the arrows. Remember, that's important.
All
so
right.
start from P and go to
PS.
S, yes, and then from S to
PR.
And this time we
but I
took
end
it
up
from
at the same
it from the
point.
clockwise perspective this
Right.
time, and we ended up at, Shariah, I think we matched this thing
So
out.
that means that the resultant vector could just be from P straight to R.
I am thinking that the resultant vector is PR.
Because if I go, what is this now? Clockwise?
No, sweetheart,
Anti-clockwise.
your clock and don't move that way.
Anti-clockwise. So if I go PQ, QR, I end up at R. And if I go PSSR, I end up at R.
So, and we're looking at it and we remember that we talked about these vectors, PS and QR being parallel and equal. That's very important because we have to remember now that we were not given vector QR.
Yes.
Neither were we given vectors, vector SR. But we
QR
have,
is the same thing as PS.
That's what I want you to point out.
And SR is the same thing as PQ.
So we talked about them being parallel and
equal.
Very important point, Latoya. So let's see if we are correct. So we made a guess and we're asking, is the resultant force or vector, as we had said earlier, is it PR?
I think so.
We found out something earlier where we said, when we looked at the previous questions and looked at resultant vector, we noticed that when we added those vectors, we ended up with the resultant vector. So you know what I want you to do for me?
Add them up?
I want you to add vectors PS and PQ.
All right, so I know that PQ is 3, 1. Let's check. So we got the horizontal distance first. So that's 1, 2, 3, movement, and then 1 up. So that's 3, 1.
All right. And I think our students have that part locked.
All right, I think so too.
But go ahead anyway.
All right, and now we validating PS. So S is that direction. So I'm going 1, 2, -2, 1, 2, 3, 4. All right, so that's -2, 4. And we're going to add those two vectors. And when I add, I'm getting 3 plus -2, that's 1. 1 plus 4, that's 5.
All right, so Latoya, we're going to add vectors PS and vectors SR, and we would have looked at this concept earlier when we're talking about the common point that is present.
Right.
And so vectors PS.
We know that that's negative.
Give me those figures
2,
again.
4.
Yes.
PS and which one now?
SR.
And that's
which we said
parallel,
is parallel and equal to
PQ, right? So that's 3, 1.
Good. All right. And so this now will give us the resultant vector, which is 1, 5.
You know what? Let's add the other direction as well and see if we'll get the same thing, which would be PQ and QR, and see if we will still get PR. So for PQ, that's 3, 1. And for QR, which is parallel and equivalent to SP, that's negative 2, 4.
All right, and I'm seeing Latoya where I'm getting the same resultant of 1,
5.
All right, so the resultant we said is vector PR, and that's very critical.
All right, I'm also going to check now via counting on the grid to see if we still get 1, 5.
Go ahead.
All right, so I'm going from P to R. Okay, so that's 1 movement on our horizontal plane.
Which direction?
Right,
okay.
to the right. And then 1, 2, 3, 4, 5.
So we are correct.
We are correct.
I think we matched it out.
We
have matched it
yes.
out. All right.
All right, so what we want to conclude for our viewers?
I think we also... So we talked about parallelogram law of vectors. So we would have established then, Latoya, that when we talk about finding resultant vectors for 2 or more vectors, we actually have 2 approaches that we can take.
Yes.
Yeah, and we would have explored them both. The triangular law of vectors, parallelogram law of vectors, and we notice why these are so named. If we remember this question, when we actually maxed it out, as we would say,
get a parallelogram.
we actually got a parallelogram.
Right.
All right, so I think we want to jump into a few CSEC questions. I'm hoping that we have enough time, because we don't want to leave our students hanging, you know?
All right.
So,
whoopsie.
Take that down too. Yes, you're running right ahead. All right, so let's look at this diagram below. And of course, we're told, and we know
not
this
drawn
is
to scale.
not drawn to scale.
Do not measure with your ruler.
Thank you very much. So it shows a quadrilateral ABCD in which vector AB is equal to M, vector DC is equal to 3M, and vector AD is equal to N. Yes, you have to stress this, you know, because the M and the N are so close. But we want to ensure that we pronounce so clearly that our students can see. So what are they asking us for?
To express vector BC in terms of M and N. So BC, start at B, end at C.
So let's look at our diagram there.
All right, so where is B? Okay, we have B here.
Yes.
And we have C here, but there is no direction on this line segment BC, which I'm thinking we can't traverse there.
But we need to consider the direction. Now they asked us to express what? Vector BC.
Right.
Which now tells us that it's a movement from B to C. Good. Now we would have explored earlier and we said that, all right, we have a start point.
Right.
B, we have our end point. C. But we're also saying that there needs to be common points.
Right.
In between those, if I'm going to be using BC as a resultant vector for 1 or 2 other vectors. So let's explore what we can
So this
do
is
with
what
this.
I would do.
All right, go ahead.
I would go BA, AD, and then DC.
Makes sense. This reminds me of the question we did with Mark and John.
Oh, yes.
It reminds me of that same question. But Latoya wants us to zoom in, you know, because students tend to make this error a lot because I see you change direction. I see you said BA, and the question told us that vector AB is equal to M.
But I know that I'm just doing the inverse.
Oh, sorry. No need to bite my head
Same
off.
distance,
Girl.
just different direction.
And how do we show a change in direction? How do we
Just
show the
by
opposite direction?
Negative.
All right, girl, you get it, you
I
get
get
it, you
it,
get
I
it.
get it.
So I want to zoom in on the screen and you would see that that negative M has been colored red for emphasis because we want our students to really pick up on that point.
Yeah.
And the rest is pretty much
Simple.
algebra, yes. So we're grouping our like terms. All right, so now we have 3M and we are subtracting M from that. What does that give, Shariah? Let's see if you're...
2m plus n.
Ah, you're bright.
Yes, I am.
So, and they did ask us to express vector BC in terms of M and N. I think we get to the answer.
So you couldn't just go ahead and measure with your ruler and give a value for BC
But
because
then-
it did say in terms of M and N. And
then-
it did also say not drawn to scale.
Yes, and then measuring to, we'll just give magnitude, talking about direction, all those things. Remember, our vector.
All right. Here is...
I think we can move to another part. Yeah.
Okay.
So this is the same question. So this is another part. So we're given an additional information now, Latoya, that L is the midpoint of CD. Midpoint.
Middle.
Half?
I think
halfway?
so.
I think that's
Halfway,
what it
yeah.
means, yeah. So we're finding vector BL in terms of
BL.
M and N. So
Okay.
I see here where we have now put in a line
Yes.
for
Line
connecting
segment.
B, a line segment, thank you, connecting B to
L.
L. All right? And so how does that affect that 3M value that we have there?
Okay.
If L is the midpoint, how does that?
half of it.
Great. So what does that mean? What is LC? Let me see if you're bright. Vector
L?
LC.
Half of 3, let's say of the bigger number.
Girl.
1.5.
Thank
Just
you.
joking.
You play around too much, you know. All right, so let's see if we can put that up so our students can see. All right, so we're asked to express BL. So walk me through BL.
All right, so BL.
Quickly, we have less.
I already know BC, so I just go BC, CL.
Makes sense.
Yeah, instead of going all the way around.
Makes sense. But I want to also point out that you went from CL. Notice where the original vector that was given, that direction was moving where from L to C. If you look at the arrow right behind where L is. So if you have changed the direction, what kind of 1.5 M? What?
Negative 1.5
So we
M.
have 2M plus N. Subtract 1.5 M. All right, and
Okay.
of course the rest is pretty much grouping our like terms, and so BL is equal to 0.5. You missed, no, go back. All right, so it was equal to 0.5 M plus N. Now, you can now bring up that question on screen. We're asking our viewers to try, look at it, determine which of these laws would we use if we're finding the resultant of vector OQ and OP.
Take a picture quickly.
That's
all
right.
That's it for part 2 of vectors. You can catch a reminder
Or a repeat.
That's
That's right.
of today's lesson. And reminder too on
Yes.
JNN later at 5 p.m. and in Schools Not Out highlights on Saturday between 1 and 4 p.m.
It also will be on video on demand on onespotmedia.com. Up next, we've got IT with Leo Lewis.
Bye.
Stay tuned.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and